Let's look at an example of an electrochemical cell. So we'll start by looking at a reaction and then see how we can use that to build a cell. So for our reaction, let's oxidize zinc and let's reduce silver chloride. So we'll reduce the silver chloride to silver, and we'll oxidize the zinc to zinc 2 chloride. Okay, there we go. So there's a reaction. Let's look at how we could harness this to generate some kind of electricity. So we can do this. We could certainly just mix these things into a beaker, but if we do that, we're not going to be able to harvest any of the energy. So if we split this into 2 beakers, we can harvest the energy that's produced. So we'll take 1 beaker and put a strip of zinc in it. Another beaker, and we'll have a strip of silver. And we'll coat that silver with some solid silver chloride. And then between these beakers, we'll put a wire, and the wire will go to something like a light bulb or something like that. So between these, we've got this wire, we've got a light bulb. Now, if you look at this right away, you can see if you've done any circuits that this is not going to work because we have a loop. We don't have a loop, and for a circuit, we need to have some way for electricity to travel in a loop. The way we solve that is with something called a salt bridge. And a salt bridge, you can think of it as a tube filled with salty jello. So in reality, we'd probably use something like agar or something like that, but I suppose you certainly could use gelatin, just some sort of gel. And the gel is going to have some method of carrying electricity. So what we usually do is put a salt. Often it's a potassium chloride. So let's see how this works. Well, we've got zinc being oxidized from zinc 0 to zinc 2. So put the zinc down here. And so if zinc is coming off this electrode, if this electrode is being eaten up, and we could emphasize that by maybe showing that this electrode is going to get corroded over time. So it's being eaten up, so we can sort of dramatize that here. That means that it's leaving behind, as the atoms get oxidized, they're leaving behind electrons. And those electrons have to go somewhere. If they were just to build up on here, we'd have an accumulation of negative charge. So they're naturally going to flow away from there. So we can show that with electrons flowing in this direction, okay, because they were being produced at this electrode. So this electrode, we can see that there's oxidation taking place there. And the place where oxidation occurs, the electrode where oxidation takes place, is always called the anode. Okay, and we need to show that this is happening in an aqueous solution here. So let's add a little water. Okay, very good. So the electrons are going this way. They're flowing, they're going through that light bulb, and so they're coming over here. And so we now have electrons here. Now, if they were to build up, that would stop the current flow. The whole thing would stop working. So we have to have a way for electrons to keep flowing through this loop. Well, fortunately, we have silver chloride here. And we see in a reaction that silver chloride is being reduced from silver 1 to silver 0. That must mean that it's gaining electrons. Oh, I didn't balance the reaction. Let's put a 2 there. Now we're balanced. Okay, so we have to somehow get rid of the electrons, and we do that by these silver atoms here that were +1 gaining electrons as electrons come down through the electrode. So at this surface here, silver 0 is reduced to silver 1 is reduced to silver 0. Okay, so we have a reduction here, and the electrode at which reduction takes place is always called the cathode. And there's a variety of different mnemonics you can use for reductions occurs at the cathode. I just like to visualize a bright red cat. So burn that image into your memory, and then you'll be able to always remember that reductions at the cathode. Okay, so we have negative charge flowing this direction, and we can continue that by using the salt bridge. So we can imagine over time we're getting rid of, they're being plated out on the silver electrode. So that doesn't leave a partner behind for these chloride ions. We have to maintain electroneutrality in the beaker here. So what happens is over time, potassium ions dissolve from the gel into the solution. So notice we have negative charge flowing this way through the circuit. We have positive charge flowing the opposite direction. Okay, let's go back over here. Remember how we said we're producing zinc ions? Well, we need to maintain electroneutrality in this beaker as well. So we need counter ions for these zinc ions. Well, we can do that by having chloride dissolve from our salt bridge. So notice, once again, negative charge moving this way through the circuit and positive charge going that way.